Okay.
Okay. Hi, everyone. Welcome to the Nova project update. I'm Melanie Witt, and this is Matt Riedemann, and we're both going to be giving the update for y'all. Matt's going to cover the Queens features, and then I'll cover what we're doing in Rocky and then beyond Rocky and all of those types of things. So what is Nova? Nova is the compute fabric, or
what? Oh, I'm just sort of blinding, I realize.
Yeah, I don't know if I can stand anywhere and not be blinded. So Nova is a compute service, as many of you may know. It's the REST APIs for creating instances like virtual machines, bare metal. So it's all of that. The Vert drivers are a part of Nova. Project background, Nova is one of the original projects in OpenStack, and this past release in Queens, we had 183 contributors, and as of the last user survey, Nova is deployed by 98% of users that responded to the survey. And so now Matt's going to tell you about the features that we have added in Queens.
Yeah, so the release notes are at the top. I'm just going to go over highlights. There's a lot more than what I'm going to cover in this slide. The cells v2 highlights, so in Pike we had multi-cell support. In Queens we were building on improving the performance of multi-cell. So in Pike, for example, if you've got multiple cells and you're listing instances across the API, we're just hitting each cell iteratively. In Queens, that's all done concurrently, and then the results are merged at the end. There's this other set of issues which we refer to as upcalls, which the ideal cells v2 deployment is where you've got a control plane at the top, which is API, conductor, scheduler, and then you've got your cells at the bottom, which are disconnected from the top by or your MQ is just not able to go from the bottom to the top. So an upcall is where something in the bottom calls back up into the scheduler or the conductor or the API database. So if you think of like the late affinity check that happens in the compute, that's an example of an upcall. The most probably common one is the scheduler picks a host, you get to the host, and for whatever reason the build fails, we would go back up to the conductor and reschedule, which involves another call to the scheduler and all this stuff. So if you've got a split MQ deployment, you can't do that upcall. That was fixed in Queens. I've got a later slide to just give an idea of that. Another thing was CERN is now on cells v2, and so they've got a developer devoted to helping out with cleaning up a lot of the deployment tooling, adding things that they needed that were gaps in the deployment tooling, just for managing cells. So there's changes to Nova Manage for doing cells v2 deployments. Scheduling placement highlights, one of the big things was you can do traits-based scheduling now. I've got a later slide that gives an example of this, but just as a refresher, in Pike we added resource classes. Resource classes are quantifiable, quantitative aspects of a resource provider. A resource provider is like a compute node. So the usual example is vCPU, memory, and disk. That's quantitative. Traits are qualitative. So these are things like SSDs, GPUs, stuff like that. And then there is also the 1.0 release of the OpenStack client plugin, so you can manage placement stuff through the standardized OpenStack client CLI. Want to hit the next slide?
Oh, sorry.
So this is a basic idea of the alternate hosts upcall thing that we added. So before alternate hosts, this is just sort of a flow of scheduling a server. You go through the API, conductor, or the scheduler, hit the first host, that fails, and then we would have to call back up to conductor, which would ask the scheduler for another host to get down to host B in this case. So now in Queens, and this isn't like a optional thing, this is basically everybody's running this, regardless of whether or not you're doing split MQ or multiple cells or anything, this is how reschedules work now for everybody. At the top level, we basically tell the scheduler, if I'm going to be doing any retries, if I'm configured to do retries, which you don't have to be configured that way, but if I am doing retries, when you pick a primary host, give me a set of alternates that are in the same cell. And then the scheduler will pass those back down. And then once you get into the cell for the primary host, so in this case, host A, if that fails, we don't ever go back up to the scheduler. We're basically stuck in the cell. And then we hit the conductor again, and it says, OK, do you have alternates? If so, yep, try again. And if you run out of alternates, it's the same thing you would get before this. And then this is an idea of trade space scheduling. So in this example, we've got 2 ironic nodes. The resource class is just called custom bare metal, because I think that's what some of the deployments have been doing just by default. Like OOO just sets a custom bare metal trait on all of its ironic nodes. And then the differences between the 2 nodes is this one's got the VMX trait, and this one's got the DirectX GPU trait. And on the Nova side, the operator can configure the flavors. So we've got 2 different flavors, the VMX and the DirectX flavor. They've got the same resource class. They're going to consume the entire node. But the way you can specify the traits differently is, for the one trait, I need to tell the scheduler this has to go on a VMX node, and the other one is I need to go on a DirectX node. I think that's basically it for that one. In Pike, we had deprecated, if you're doing ironic deployment, you're aware of the exact filters, exact RAM, core, disk, and the fact that you have to specify a different host manager to the scheduler, the ironic host manager. That was all deprecated in Pike. It's still there in Queens, but we've dropped it now in Rocky because basically you can have the unified scheduler now. You don't need to do this weird extra step for configuring scheduling for bare metal. This is an overview of the major REST API changes in the compute API. The 254 micro version is that you can specify a key pair when you're doing a rebuild now. One of the examples is you lost your key pair. You forgot you need to just provide a different key pair for your pet to get into it. Or you've got multiple people on a project. Jim created this super awesome pet VM that you can't get rid of because you just need it, and he left the company or something. You need to get into that thing, so you're in the same project, so you can still rebuild the VM that Jim created, but you can specify your own key pair to get into it. 255 adds a description field to the flavor resource. This is pretty basic, but it was something that bare metal operators were asking for, so they can actually specify something that would explain what this flavor is going to be for a bare metal node instead of trying to encode all of that into the flavor ID. 256 is feature parity with live migrate and evacuate, where the admin can specify a target host to cold migrate the VM. The one big difference with this and those other ones is the other live migrate and evacuate have a force option so that you can bypass the scheduler and shoot yourself in the foot, cause all sorts of problems. With cold migrate, you can't do that. So you can specify a host, but we're still going to run it through the scheduler to see if it makes sense. 257, the thing that I don't have listed here, but I'll mention, is that we deprecated personality files, which are also commonly referred to as file injection. That's been something that we've talked about for years, and then we finally actually did it. If you want to know the reasons why, there's a spec that goes into several reasons why we need to get rid of file injection. But the replacement for that is user data, which you've always been able to specify when you create a server, but with this microversion, you can specify when you're rebuilding a server. 258 and 259 are basically sort of the same thing, but it's just parity with being able to filter server action or page over server action. So if you've got a public cloud and you've got some pet instances that get moved a lot, or they just have a lot of actions on them over time, instead of getting back 1,000 action records, you can page over those and you can filter them by when they were last updated. Same thing with migrations. This is a multi-cell operation to just page over migrations in your cloud. Some other improvements: volume multi-attach is now supported with the libvirt compute driver. That's at the microversion 260. There are some QEMU and libvirt version dependencies. You have to have some minimum versions of those. There was a talk on Monday that goes into more detail about this, and it's recorded, so if you want to know more about this, you can watch that. There's also docs in both Nova and Cinder. There's limited virtual GPU support in both the libvirt and Zen API compute drivers. There's Nova admin documentation for what the restrictions are, and there's some ongoing work in Rocky to close some of those gaps. The next one is there's native QEMU volume encryption. So before this, you couldn't do encrypted volumes with RBD Ceph or Ceph volumes with the libvirt driver, you can now do that. Again, there's minimum required versions of QEMU and libvirt to do this. A long-standing issue that we resolved in Queens is that the way that we store IP information about a server is basically just a serialized JSON blob in the database, which means that if you're listing across 1,000 instances in the database and you need to find one because you're trying to track down a malicious user, it can be very slow because we've got to pull all the records out of the database, deserialize the JSON, and then do a regex check in Python. This was a change on both the Neutron and Nova side. So Neutron's got this new ability so that Nova can just say, hey, if you've got this API extension available, you do the filtering in SQL for me, and then we filter out the results on the Nova side. And I believe the contributor that added this posted some results in the mailing list, and the performance on this was just like ridiculously much better. We're continuing to work on transforming the legacy notifications to version notifications. The link here will take you to a doc that has all of the version notification payloads. Another thing that we continued in Queens, and I think got everything except for this Cinder configuration, but this is basically standardizing how Nova is configured to talk to all of the other services. So Ironic, Neutron, Glance, Keystone, Barbican. Before, everything was a little bit different. If you wanted to specify the admin URL, there was different ways to do that between all of the different services that you had to configure Nova to talk to. That's all standardized now, and a lot of it is you can just, if you're using basically a default deployment for how Keystone identifies services, some of the stuff you don't even need to configure anymore. It's just out of the box default. And then the last thing I wanted to mention here is there's now TLS encryption support for VNC consoles with the libvirt driver. Again, documentation on Nova for any caveats with that or minimum package version dependencies. And if you want to stand over here, it's a lot easier to see.
Okay, thanks. Okay, thanks, Matt. Now we're going to talk about some of the things that we're working on in Rocky or have actually already implemented in Rocky. And then you can go to that URL to see all of the spec designs for the things that we've targeted for the Rocky release. For cells, we now have support for disabling a cell, and what that means is to disable it to prevent it from being scheduled to. So the use case for that would be you want to perform some sort of maintenance on a cell and take it out of rotation temporarily. You can now disable it via Nova manage commands. We've been working with CERN a lot on some cells features like disabling a cell. They've been really helpful in working with us to let us know what features are missing or what things aren't working very well. So we've been doing a lot over there. Another thing we did is that we have console proxies to run per cell instead of globally for the entire deployment. And we have deprecated the Nova console auth service. So the old way is that the Nova console auth service had its own storage for storing console token authorizations, and we've moved the storage to the database instead of using like a separate storage area for that. And with that, since the console proxy needs to be able to talk to the cell database, it just has to be local to that cell. So this has another like side benefit that instead of having to run one or some set of console proxies at the top for like your entire deployment, now it's more compartmentalized per cell. And then, as I mentioned briefly, various Nova manage commands, tooling for managing cells that's come out of the feedback that we've been receiving. In scheduling placement, one thing that we've added is placement request filtering for scheduling. And this is pretty cool because the old way of doing scheduling was to like pull all of the compute nodes first and then filter over all of them to find the subset of compute nodes that would satisfy the request. Well, now that we have placement, taking care of allocations and resources, we can ask placement first for what are the compute nodes that could possibly satisfy this request as a first step to just cut down that list of all to only things that have room for the request. And so that infrastructure is in place now. That speeds things up a lot. And where there's more filters that we can add to that, we're going to move any scheduler filters that we can to this system to do the pre-filtering through placement and then eliminate the need to iterate all over all of the compute nodes to filter. Another thing we have for placement is granular RBAC policy rules for placement API operations. So previously it was admin only for the placement API. There's no way you could control or choose the rules for who could call the various placement API functions. So with this, it's just going to make it like policy based for each API, just like the Nova APIs. You can choose which roles or people that you want to be able to call those APIs. Another thing we're working on is NUMA-aware live migration. So currently, for live migration, the CPU pinning isn't recalculated when it gets to the destination. So you get in this situation where everything's fine, and then you want to live migrate that instance, and then when it gets over to the destination, it may no longer work because that same exact CPU pinning may not be available. And also the resources aren't claimed on the destination either, so something could come over and take your CPU pinning resources. So that's being solved this cycle. And then finally, a thing called nested resource providers, which I think we've mentioned before that you may have heard about. And this is basically, to oversimplify, it's just the ability to nest resource providers underneath the compute node. So you have the compute node being the root resource provider, and then underneath there you can nest things like PCI devices or NUMA things or FPGA devices, things like that. So this is kind of building this infrastructure to let people express those types of resources that are sort of owned underneath a compute node. Other things we have in Rocky, we have this new thing we're trying out called review runways. This is just a project process thing, but we're trying out a system where we have a place where you can enter a queue, like with your blueprint when you're ready for code review. You can join this queue saying like, my approved blueprint code is ready for review, and I'd like a dedicated spot for the core team to come and review my work. So the idea of this is to just get everybody on the same page, looking at the same code review at the same time kind of thing, and to help us organize reviews better. So that's something that we've been trying out. Other things we're working on, continued vGPU support, as Matt mentioned earlier. The initial support in Queens was just to allow you to request a quantity of vGPU resources. And this cycle, we're adding support for display resolutions, display heads, and then being able to have different vGPU types on a single compute node. That work it depends on the nested resource provider work, like many of the projects we want to work on do. Another thing we have been working on in Rocky is the Nova Managed DB purge, and what this means is, you can do the table archive where it archives the deleted rows and moves them to the shadow tables, and then this purge is another step where it'll delete the stuff out of the shadow tables, like permanently delete things. So this is something that we should have had a long time ago, but we finally have it now, so you can actually get rid of all those extra archived records in your shadow tables. Another thing is the ability to abort queued live migrations. So currently, it was only possible to abort running live migrations. And so this work is adding some queuing system to live migrations so that they're all waiting in a queue. And then if you decide, I don't want to do that one anymore, then you can choose to abort that live migration. And then finally, libvirt CPU model extra flags. This gives you the ability to specify in the NovaConf extra CPU flags that you want to enable in your deployment. And I mentioned this one because it's useful and needed for mitigating the meltdown inspector update performance degradation. We actually backported a version of this that will let you set the flag needed in earlier versions of Nova to mitigate that performance degradation. Next, we have a lot of cross-project work we've been doing. The first one is the Cinder multi-attach volume improvements. In Queens, we added the ability to multi-attach volume, which is the ability to attach the same volume to multiple instances. And currently, that can only be done in read-write mode. And one of the improvements we want to do is to be able to allow you to specify if you want it to be read-only or read-write, and then also give the ability to pass a volume when you're creating multiple servers that you want to attach to that same volume. With the Neutron team, we've been working on reducing network downtime during live migration, and this will involve just leveraging a new port binding API that they have in Neutron. So we just need to implement on our side to start using that to reduce the downtime. Another one is bandwidth-aware scheduling. This is, again, going to leverage the nested resource providers and placement because Neutron will be able to report to placement bandwidth information for the devices under compute nodes, and then we'll be able to leverage that through specifying, like as a user, you'll be able to specify in your flavor what bandwidth you require for your request. And then the scheduler will be able to call placement and say, like, only return me compute nodes that have network cards that can support the bandwidth that I need. With the Keystone team, we've been adding RBAC support for scope types on our policy rules. And this has to do with the work in Keystone around default roles and scope types that you may have heard about. They're basically coming up with a way to provide a reasonable policy file or setting for out of the box. So there are things like the admin role, the auditor role, which is a read-only role, member role, which is like member of a project, and then there are scope types like project scope or system scope. And we're taking that and applying it to the roles that we have, or the policy rules that we have in Nova. With the Barbican team, we've been working on adding trusted certificate support in Nova. And this has to do with glance images. Glance images can already be signed. And the thing that's being added is the ability to validate certificate along with that. So with this, once we're finished, you'll be able to specify trusted certificates with your request, and then Nova will go ahead and verify that for you when you're creating an instance or rebuilding one, I believe. Mm-hmm. And then finally, we've been doing a lot of cross-project design work with the Cyborg team on accelerator management. This is another thing that's dependent on nested resource providers and placement. And this will give the ability for Cyborg to report accelerator resources that it has available to placement. And then similarly, through the flavor setup, you'll be able to say, like, I need an instance with these types of accelerators. And Nova will go and the scheduler will ask placement, which of the compute nodes have these accelerators that I need, and then it'll select the compute node, and then the compute node will connect the device to your instance. And this is like a picture, maybe an oversimplified picture of kind of like how that works. I just wanted to show what will become possible when we finish nested resource providers this cycle. And there's not much work left, so it's going to be completed this cycle. So as you can see, that's just an example of how you may have a custom resource class for your accelerator to specify through the flavor. And then Cyborg will call this update provider tree API of placements. And that's how it will tell placement about the accelerators and put them under the correct compute nodes. And then Nova Scheduler will call placement, get the possible compute nodes. One is selected, it goes to Nova Compute, and then Nova Compute will do the attach via thinking it's going to be a OS accelerator library similar to OS Brick and OS VIF. So that's kind of the type of thing. And the neutron bandwidth aware scheduling will be similar. Okay, so beyond Rocky, some of the things we're looking at. Extracting placement from Nova. There was a session on Monday about this. This is just doing some work to kind of make clean seams for extracting placement from Nova as a standalone service. Accelerator management, as I just showed. It's been mostly design work, but now that nested resource providers is going to be completed, we'll really be able to start implementing that for real. Preemptible, so there was the session on Monday too. For those, since they already happened, you can take a look at the Etherpads for those. Preemptible instances. This is, you may have heard about this before. This is the same concept as like a spot instance in AWS. So some people from CERN and other folks are working on figuring out how we could do this in OpenStack. And that's something that we're actively working with the community to come up with a way to have a class of instances that will be have unlimited quota and can manage taking them down when capacity is high and then letting them run when it's not. Additional placement request filters. I touched on this earlier. We just want to move more and more filtering to the placement query that we can to pare down that list of compute nodes earlier and run filters across less compute nodes. Continued removal of the upcalls, like Matt mentioned in the Queen's features. You mentioned the late affinity check, which relies on communication from the compute node up to the scheduler. So since in a multi-cell split message queue environment, this is not possible. The compute can't actually talk to the scheduler. So we're going to have to do modeling of affinity and placement to address this so that affinity will work well in a race situation, I guess. The late affinity check was for affinity-related races. And then finally, handling a down cell in a multi-cell deployment. We've been working with CERN on this. This is like a reliability thing or a resiliency thing. In a multiple cell deployment, all of your databases, your cell databases may not be having similar connect times. There could be one of your cells may be in a remote location, so that database responds much slower, or a cell may go down because there's something wrong with one of the other cell's databases, and we're working on things to make Nova work well even in the situations when that is happening. Okay, so How to give feedback. This is just how you can talk to us and give us your feedback as you're using Nova, like anything problems you've been having, what's missing, and we've been doing like a lot of new work, so getting feedback about all of that is really helpful so that we can make changes. So definitely leverage the mailing lists, the OpenStack Dev and OpenStack Operators mailing lists. We all read those constantly, so that's a great place to start a conversation if there's anything that you'd like to discuss about Nova or anything that you'd like us to work on. Okay, so attending the forum sessions, this is a little awkward because these already happened, but
But some are recorded.
some of them are, okay. If any of them are recorded, then you can take a look at that. I put the link there for the session Etherpads to take a look at that. So, but in general, yeah, like come to PTG, come to the forum sessions, let us talk to us on the mailing lists in our IRC. Okay, how to contribute. We have some contributor documentation linked there. Get on the OpenStack Dev mailing list. Use the Nova tag for when you do your posts about Nova. You can always find us in the Nova channel on Freenode IRC. We have weekly meetings that alternate for time zone. There's like a US time zone one, and then alternating with a Europe time zone friendly time. Always helpful to have people lending a hand with bug triage. And the earlier slide I should have mentioned, like reporting bugs is super helpful. That is how we can like be aware of the things that are going wrong or be able to fix things. So there's how-to docs for how to do bug triage, and there's a presentation from Sydney, I believe, about how to do upstream bug triage. And then finally, you can attend the Nova onboarding session, which is today after lunch.
The one thing that hasn't happened yet. I know.
Yeah, that's the only thing that hasn't occurred yet, yeah. Other ways to contribute, help with code reviews. This is always a good one. And this, for me personally, this includes like letting me know there's a code review that maybe hasn't had attention that's important. Just ping me and let me know about it. Doing code reviews helps. If you all do code reviews, that helps too, to have more eyes on the patches. We could use help cleaning up the docs, obviously. If you notice anything wrong in the docs, like definitely let us know or propose a patch to correct anything that's wrong. Reporting bugs, again, is really awesome. If you've done any scale testing at your organization, like if you could do a short email to the dev mailing list and just let us know what you found or what you noticed, that's always great to know. And it'll help us know, like we can dig into it further if we have just like a hint from you.
This is even just very informal. Like I think it was last week, CERN was like, yeah, everything's going pretty well with Cells v2, but there's like this one thing in the scheduler. And like 3 of us are just looking at it, it's like, oh, it's probably this. And half an hour later there's a patch. So very easy and informal if you just have stuff like that.
Yeah, definitely. And then proposing backports to stable branches. Stable branch backports are just kind of whoever has interest, like if there's an interesting patch that you think would be useful on stable, just propose it. That's kind of how we consider backporting things. That's it. Does anybody have any questions for us?
We have one question.
Oh, good. We have a question.
Nested resource provider. So I guess this is the way to expose the PCI devices. In Rocky, will we be able to do quotas on that?
There is a spec, right? Where's Alex? I know Alex
Yeah.
is in here.
I don't.
Okay.
Okay. So Alex isn't here, but
We can take it off.
Yeah. So there's a spec being reviewed right now that's about that. It's about being able to specify quota limits for custom resource classes. So anything that would be represented by a custom resource class, including that, that's going to be that spec.
Okay.
So.
And this is for Rocky or beyond?
The spec is proposed for Rocky.
Okay.
At this point.
Cool. Awesome.
Yeah.
We've already got a lot on our plate, so don't hold out hope. But
Okay.
Yeah, technically it could be approved for Rocky, but I would say not likely that it would be done
Fair enough.
by Rocky. Yeah.
there was also a placement presentation, was that yesterday? So that's also recorded. People can watch that.
Hi, thank you for the presentation. I just have one question regarding image backend. As far as I remember, there was an initiative to some kind of replace image backend with Cinder and Cinder volume drivers. And what is the state of this work? Is it still in progress, or it's just postponed?
Yeah, nobody ever stepped up to own that. The question was, with Liver, you can have multiple different ephemeral image backends, and people want parity with their block storage device driver. And so one of the ideas was, and I mean, we already have like an RBD one. A lot of the answers was like, well, if we could just have a single like Cinder driver that did all of this for you, that would be awesome. And then we could get all these like vendor specific things out of there, and you can just, you're already doing it in Cinder, you could just use that, but nobody's ponied up developer resources to actually work on that, so.
We can mention that what we're thinking as a way to address that is to possibly make boot from volume a first class thing in Nova.
Yeah, this is the second question. Yeah.
Yeah, like realistically, trying to implement the Cinder image backend it's just going to be really messy and like a huge amount of work. So we were thinking, would it work for people if we make boot from volume first class, fully supported, and then that you can get any Cinder backend that you want via the volume. That way, we don't have to try to re-implement stuff in Nova.
Yeah, there's some specs up. I can't remember if any are merged, but there have been some specs up for basically just API feature parity. So things in the API that you can do at an instance that don't work for volume-backed instances. Yeah. I think like Rescue is a good example, stuff like that.
Rebuild.
Right, yeah, rebuild. The rebuild one is really tricky, and there's been a mailing list discussion on that. So there's ways to like hack that and make it terrible and get it done, but this is kind of why like some of that stuff takes time. But
so what if we would come with some patches towards this movement? Would it be appreciated or something?
For the rebuild one, I mean...
No, not rebuild, but Cinder workflow at all.
For replacing the image backend?
Maybe, yeah.
You can push up whatever you want for code review. I mean, depending, I think Fyodor Tursin had done this at one point too. Or maybe it wasn't the Cinder thing, but it was completely like refactoring all that code, and it depends, so.
Okay, thanks.
Yep. I think we are, nope, go ahead. I think we got like 30 seconds.
I heard recently, I think, something about the flavor where being removed.
The type affinity filter?
Yes.
That didn't work if you ever modified your flavor or anything?
Something to do flavor stacking. We have,
sure.
Like we have, it's a whole Tetris thing.
Yep.
And we use that to make sure, like our most common flavor is like 50% of a compute node not over provisioned.
Yep.
And so we don't want to have a 50% VM and then have a very small one come on, so another 50% one can't come on.
Yep.
And it sounds like that's going away.
It's already gone in.
Yes, and what version has that gone in?
I I want to say Rocky. I want to say it was also deprecated like a year ago. But I realize people are behind.
Is there any other sort of thing to replace that?
Nobody's proposed anything to replace that. I mean, we also blasted the mailing list with like, is anybody using this? Because it's got problems, and nobody said anything.
Yeah.
Once we removed it, I've heard people saying, you know, we care about it, but.
Okay, cool.
Okay. Oop.
Hi, I have a question. When we launch the VM, and if we want to take a snapshot of running VM, then it's stored as a glance image.
Yep.
Can we, using that snapshot, can we store it as a volume?
You can create a volume from that snapshot image, yes. Right, we
But
can talk after the
let's
session.
say if bootable volume is 100 GB, then the glance image will be 100 GB.
Okay. We'll have to talk after the session. We're over time, I think. So.
Thank you.
Yep.